Hello, and welcome to this ANSYS Space Claim tutorial on cleaning up and repairing an STL file. We're going to be working in this Facets tab, where you'll see this cleanup group with a few different tools we'll explore today. When you start Space Claim, you may be in the Design tab, so you just want to go ahead and click on the Facets tab. Now, I already have the part loaded here, but if you don't, you just want to go to File, Open, browse to the folder that you downloaded it to, and initially you won't see any file here, and that's because the file filter is set to Space Claim files. You'll just want to change it to STL or all files, and then you'll be able to see the STL file there and go ahead and open it up. Now, when we first open it up, it's always a good idea to take a look at it. If we spin it around to some different views, we can clearly see some openings in our parts. We definitely know we have to fix those. But it's also a good idea to take a look at the icon in the tree. Now, if I switch over to a different tab where I have a nice clean STL cube, you'll see in the tree here we have an icon representing a solid mesh. If we go back to my imported steel die STL, you'll notice it looks like an open surface body. So this is a STL that is not watertight. But what we're going to do is we're going to see how some of the tools here can tell us the same things and also help fix those. And what we're going to do is we're going to look at this cleanup group in the Facets tab, and we're going to look at these tools: check mesh, auto fix, intersections, holes, and fix sharps. Now, I do want to state right at the beginning that you should not just open up an STL file and run all of these tools. First, gain a good understanding of what they do, but also what does your mesh or STL file need. For many purposes like reverse engineering, you won't need to run any of these tools, but also some printers and based on the quality of your scan will determine whether or not you need to do things like fix sharps. So we definitely recommend testing out these different tools along with your equipment to make sure that you're not running these tools when you don't need to. Now, whenever you open an STL, it's a good idea to check the mesh. So all you have to do is turn on the check mesh tool. And as the status message right here tells you to do, you click on the mesh body to check for problems. Now you'll notice in the tree we have a single mesh item or mesh object, and this is typical in opening STL files. Now this is a single part, but if it was multiple parts, one of the messages we'd get here under check mesh would be that it's multiple bodies. And typically, before we run any of these repair tools, we do want to separate a single body into multiple bodies. And in a future tutorial, we'll take a look at using some of these separation tools. But here we can see that there's two problems with this mesh. It's not watertight, and that was evident by the holes we saw in it. And it's also self-intersecting, and what a self-intersecting mesh is that some of the triangles are overlapping and they're not trimmed properly. So let's go ahead and close out this check mesh tool, and I'm going to go back to my select tool. Now what I want to do is I want to see what tools I should use here, and the auto fix tool says that it attempts to automatically fix any meshes in the design. And what I can do is while I'm hovering over this, it says press F1 for more help with that tip that's showing up. And if I do that, it brings me right into the help page for that tool. Now, this is the downloaded local offline help. You can get this in myspaceclaim.com using your login. The default help is now online. And we'll see here that if I go down to automatically fixing a mesh, it outlines the steps that the autofix tool does. First, it fixes self-intersections. Next, it'll close holes. Sometimes closing holes results in new self-intersections, which it'll check for and fix again. And if there's any internal bodies, it'll remove those because those are usually not printable as explained down here. And the autofix tool will also fix any normals that are in the wrong direction. So we saw that the autofix tool first does intersections and holes, and then it goes back and redoes the intersection. So let's take a look at how the autofix tool fixes some of these holes. And for that, I'm going to zoom in on this area here where we could clearly see there's a piece of this cylinder missing. Now, if I go ahead and I turn on the autofix tool, it says click a mesh body to automatically fix defects. So we'll go ahead and do that. It runs through the different repairs outlined in that help file. And then when it's done, I'm going to either hit escape or click on the select tool to exit out of autofix. And if we take a look at the way it fixed this hole here, we could see it created a number of new facets from one side to the other. But you'll see that it kind of went straight across. It didn't really do a nice round cylindrical patch. Now, after doing an auto fix, it's important to do a check mesh because a lot of times if you have a really bad STL that comes in, sometimes the initial repairing may introduce a few other problems that we need to fix. So if I do a check mesh again, we could see that the body contains a non-manifold vertex. And if I go ahead and select that, it'll highlight it in the model. And so I'm going to go ahead and zoom in on these, and I'm going to just move this window out of the way here. And so if we zoom in, it's highlighting that area where it's a non-manifold vertex. And the way to fix this is to delete those facets and use autofix to patch that back in. So I'm going to close this window and hit escape or select to close out of the check mesh tool. And here I want to delete a number of facets around here. So there's a few different workflows I could use. I could hold Control and click on each individual facet that I want to delete, but that might take a while. So what I could do is I could drag a box around the facets that I want to select. Now, a couple other methods that are really useful with meshes, if you look down in the bottom right, you can change the box select to lasso select. Lasso select allows me to draw around the facets that I want to select, and it'll pick any inside of those. But the one that I find to be the most useful for working with STLs is paint select. And paint select allows me to simply drag across some facets and it'll select those. And I'm just going to hit delete on my keyboard to remove them. Now we can see here some weird overlapping shadows and edges here. So I might also want to take those and delete them. And when I do that, we can see that there's actually a facet that was hiding underneath here. So I'm going to select that one too and delete that one as well. So I've now deleted that area. And you can see that if we patch that back in, the area was kind of rough to start with. It'll patch that in nice and cleanly. Now I am going to do a check mesh again just to find that other non-manifold vertex, which is right down here. So we'll go ahead and zoom in on this area here and we'll close that out and I'll hit escape. And it's just this area here and I still have that paint select on. So I'm just going to go ahead and drag across some of these facets here. Hit delete on my keyboard. There happened to be one extra one hiding here, or in fact, there may have been two extra ones hiding in there. And that's what's really making that non-manifold vertex. So I'm just going to click to select those and delete. I now have these two openings here and we'll run autofix one more time. Escape out of the autofix tool. And you can't even tell where those openings were. It just patched it in. Looks like the rest of the geometry here. Now we'll do a check mesh one more time. No geometry problems were found. So you can see that using the check mesh and autofix and then deleting some bad facets is a super quick way to turn a non-watertight corrupt STL into a nice, clean, watertight, solid STL. Again, the only limitation is the way that it caps in those faces right there. So we can see that this one is flat across instead of following the contours. And same thing on this one. It did a flat straight across capping instead of trying to patch it in following the contours. So I'm going to go ahead and just going to open up this part again to show a more manual process that gives you a little bit more control than the autofix. Now, one thing I do want to mention with these tools that I'm about to show here is that you don't always have to use these tools. If you're bringing in an STL for the purpose of reverse engineering, you probably don't have to use any of these because you'll just be creating some sketches using the STL as a reference. If your goal is to 3D print it, usually the only thing you need is a watertight STL with clean intersections, and that's why the autofix tool does a really great job of that. But what I'm going to do is I'm going to show the manual tools we can use to fix intersections and holes, and also a tool that fixes sharps. And again, this is an optional tool. We recommend trying this out with your printer depending on the fineness and resolution of your STL and the resolution of your printer. You may not need to run any of these tools here. So it's always a good thing to try out these tools along with your printer. But so remember that when we did the check mesh, it found that it was not watertight and it was self-intersecting. And usually what I'll do is I'll run the holes tool first in order to patch these in, and then I'll fix the intersections that may have resulted from those holes. Now, the difference between the holes tool and the auto fix tool is that you have control over how the holes are repaired. So let's go ahead and I'm going to zoom over to this side right here where we saw this cylindrical patch or this cylindrical hole, and we'll see how these two different options work. Now I'm first going to show you the cap option. If I turn on cap and I click this hole here, you'll see that it makes facets that go straight across. It does not follow the cylindrical contours of this part. So this is pretty similar to the way the AutoFix tool works. But I'm going to undo that. We have a nice undo button in the upper left, Control Z to undo as well. And I'm going to show you the patch option. And what patch does is it tries to follow the contours of the neighboring geometry. And we can see that it's curving a lot more, following the curvature of the surrounding facets as opposed to going straight across. And if you ever forget which is which, again, you could always hover over it and this little tooltip will appear explaining what each option does. And so we typically recommend looking around the model, seeing which repair should be used. You know, for example, this is part of a cylindrical face. It should be patched in. And we can see here it makes that nice curved patch using the surrounding facets as guides. Same thing with rounds. We typically want rounds to follow the curvature that's there, remain tangent to the other faces. We could go ahead and click those. But sometimes you may have a few that you want to apply with the same method, so I could always drag a box. And here I want to switch back to my box select. I'm in Paint Select. So here I'm going to drag a box around these, and if I hit the check mark, it'll only go ahead and fix those. And we have a couple other ones here that we want to use the patch option with, so I could select those with the patch option on and hit the check mark. And last but not least, we have two that need to be capped, so I could just turn it over to cap and hit the check mark. If I hit the check mark without selecting anything, it'll go ahead and fix all that are shown with the option that I have selected. So we've gone ahead and fixed those holes. Let's just do a check mesh to see what we have left here. And we see that the mesh is self-intersecting. So we have intersections we can deal with, but we might also want to fix some sharps. I just want to show this tool before running the intersections tool. So if I turn on Fix Sharps, it looks through the model based on sharp edges and sharp vertices. And I just want to zoom around to a good angle to show you what is meant by a sharp. So if I zoom in here, we can see that we have these little areas protruding out. And this is a sharp. Again, these may not necessarily need to be removed for 3D printing. But here what I can do is I can just click on one of these and you'll see that it knocks that down. And there's two kinds of sharps. You'll see on the side there's a convex and a concave, basically one that sticks out and one that goes into the model. And here's one that goes in. There's a little cave or pocket inside of here. And actually two different edges are found based on our search parameters. And you'll notice if I click this one, it first knocks it down a little bit and I have to click it again and click it again. And that might not work too well. So if I undo, you'll see that if I click the other one instead, it goes ahead and it removes that cavity or that cave a lot easier. Now these default search parameters are usually pretty good, but you'll notice it's finding 256 here. With the sharp edges parameter, notice there's a little drop down here with a slider. And if I slide this to the right, making the angle bigger, it finds less, from 256 to 40. We'll go ahead, I just want to put this back at the default here. The default for sharp vertices is 270 degrees. Here it's the opposite. If I slide this up, it finds more, 300, eventually 400. It finds more based on a higher sharp vertices angle, and it finds less based on a higher sharp edges angle. But we'll go ahead and turn these back to the default here. These are the kinds of settings that you'll want to play around with based on the size of your model. But again, you do not necessarily need to remove these sharps in order to 3D print it. But if you do determine that is the goal, instead of clicking them individually, which may take a while, notice if I click the check mark, it reduces it to 36. If I click the check mark again, it goes to 26 and 6, 4, 1, and now there's no more left in the model. So I'm going to go back to my select tool and I'm going to run the check mesh tool one more time. And the interesting thing here is notice it says no geometry problems found. Remember that when we did the initial check mesh, it said there were holes in the model, that it wasn't watertight, and that there were self-intersections. And when we did the auto-fix tool, it fixed the holes in the self-intersections, but it introduced a non-manifold vertex, which we had to delete and then patch in using autofix. But here, using the manual method, all I've done is I used the holes tool to patch in the holes, and I used the fix sharps tool to knock down those little sharps and those little cavities. And by doing that, it actually fixed the intersections, and it didn't result in the non-manifold vertices. So you'll notice here that using some different combinations of these tools, you may get to an STL where no geometry problems are found. So there's really no set recipe of you have to use every tool or use them in a particular order. The goal here is to have no geometry problems found, and that can be done with the auto fix tool, which is really quick, but it can also be done with the holes tool that gives you more control over patching, and you can fix sharps, and you may need to run intersections as well. And in the case of the non-manifold vertices or edges, you just want to delete those facets and either run the holes tool or the auto fix tool to patch those back in. Thanks a lot and have a great day.